Working with an array is similar to working with a vector. One difference is we can't enter elements using the pushback method that we have available with vector. That method is not available for array. So we'll use direct assignment. Let's demonstrate how that works first by creating an array of 10 elements. And having done that, let's back up for a minute and think about what we're trying to do. With a vector, we were always able to use the size function to tell the size of the vector. We can't do that with arrays, so what we need to do is create a constant and assign that constant the size of the array and use that constant in our code. So let's redo this little array initialization, and rather than hard code the number 10, let's use the constant variable size. Having done that, we can direct assign a couple of values into the array. Number sub 0 equals 1, number sub 1 equals 2. Let's write a for loop to finish that off. So we'll start at I equal 2, I less than 10, plus plus I, and we'll write numbers sub I is equal to I plus 1. That should get the rest of the numbers 3 through 10 into the array. If we want to sum the elements of the array, we can do it just like we did with a vector by writing a loop again. So we'll write another loop for I equals 0, I less than size, plus plus I. This way we don't have to try to keep track in our minds what the actual number is for the size of the array. We just use the constant. Much easier to keep track of. Whoops, one thing we need to do before we can compute the total, we got to have a variable to store the total, so we'll add that in. And then we just write total plus equal numbers sub I. See out the total is total indel. Let's build and run that program. And we see it's 55, and that is the sum of the integers 1 through 10. One thing you have to be careful with arrays is going beyond the end of the array. In some languages that produces a runtime error, but in C++ that does not. You have to keep track of the end of the array, and that's why we use the constant size. That's why in vectors you have a function that tells you that. To demonstrate what happens if you go beyond, let's just write out a couple of values past the end of the array to see what happens. If you just go 10, which is 1 past the end, you probably won't get an odd number. So we'll do that number. And then we'll do 1 past that, 11. And let's see what we get when we run this code. First we'll get the sum. All right, so it's still showing us that it's the last element of the array. Let's change this last number. Let's go a little bit higher. Let's go 15. I'm sure that will take us beyond. And there we get 0, which is odd. What it's doing is it's just picking a random value out of memory. We could also, let's change it again. Let's put 23 there. Run it again. And this time you see the value is some number up in the billions, it looks like. Again, that's just a random memory value that doesn't have any relation to anything that has to do with the array. But it's not a mistake to try to pull out the 23rd position of the numbers array, even though it really only goes up through position 9. 9 is the upper bound. So it's up to you as the programmer to make sure that you do not go beyond the upper bound of the array. Let's work another example. Let's compute the average of an array of grades. We'll keep it fairly small. So the first thing I want to do is comment out the code from before. We'll do just 5 grades this time. So we'll set our size equal to 5. We'll use an initialization list to create the array. We'll keep it even numbers so we can make sure our computations are right. So there's our array of 5 elements. We'll create a total variable, initialize it to 0, and then we'll create an average variable. We loop through the array for int I equals 0, I less than size. See how size really comes in handy. You don't even have to think about what the number should be. You just use the variable. Total plus equal grades sub I to get the total. And then to get the average is equal to the total divided by the size. Again, so nice to have that variable there, or that constant there. And then we can write out the average. And let's build and run the program. And the average is 80, which is correct. Let's look at one more example. Let's do something a little tricky this time. I'll comment out this code. This time I'll just change the ending down to here. You can build a string by creating a char array of letters. All right, so for example, I can write char word. But first, before we do that, let's create a size. Int size equals, what's it? We're going to use let's do just a simple little 3-letter word because we're going to demonstrate a simple palindrome. So we're going to say size. So let's do constant int size equals 3. We're going to do Bob. It's going to be our word. But we're going to create it using a char array. So we're going to say char word. We could put the size here, and we will since we know it, but we don't have to because we're going to do an initialization list with char characters B, O, and B, and close it. Now, to tell if it's a palindrome, we have to reverse that. So we can create a reversed word variable, string R word, and then we can simply loop through the char array to build R word. So we'll say for int I equals size minus 1, because we want to start at the last position, which is always 1 less than the size. I greater than 0 minus minus I. See what we're doing? We're working backwards. R word plus equal word sub I. And then just to verify that it worked, let's see out the R word. Kind of do this as a debugging step before we move on to check to see if it's a palindrome. Of course, we know it is, but we're still going to look. Made a slight mistake. In this case, we have to go equal to 0, since we want to get the 0th position. Common mistake to make. So we change our loop control relational expression to read I greater than or equal to 0. Run it again, and there see that R word now is equal to Bob. So then we can simply check to see if it's a palindrome. Let's change the char array to something that's not, just to demonstrate. We'll stick with the size of 3. We'll put the word the in, build it again, and see that the reverse of that is EHT. And if we wrote a little simple function to compare the two words, we could see that the is not a palindrome, but Bob was. So those are some examples of how you can use arrays in problem solving. And in the next lesson, we're going to talk about how we can pass arrays as function parameters and function arguments.